This is a video walkthrough of the code contained in the Lists and Dataframes chapter. So to start off with, data can be organized in a number of different manners, two of which you will likely encounter frequently are lists and even more frequently data frames. So to start off with, you can make a list rather than just simply reading it in. So for example here, we can make a list of odd numbers. So we've named our list right here. We're calling it odd. And this little symbol again means assigning. And we're using these 5 numbers right here. So this little C you can think of as meaning combine or collect. So we're collecting these. So if we were to run this line of code, we can see here it says, okay, hey, I ran this. And if we look over here in our environment now, we see that we have this right here, and it contains the numbers. It contains 5 of them, 1, 3, 5, 7, 9. We can also make a list of words, of strings. And so here we have named this one gender, and we're assigning these 4 options to the gender list. So male, female, non-binary, prefer not to respond. So again, if we were to run that line of code, we can see it ran down here. And if we look over here, so it's alphabetizing things for us, we can see that it's a character list. It's got 4 options, and we can see male, female, and non-binary. So it kind of runs off the screens because it doesn't have enough space to continue. We can also, if we were making like a sequence of numbers, perhaps you needed to make an ID list, just like generic 1 through whatever IDs. Rather than type out each individual number like this, you can make a sequence of numbers. So here we're assigning numbers. That's our list name. And we're saying we would like a sequence, please. And we would like you to start at 1, and we'd like you to end up at 10. So if we run this line of code here, here's our object now. Integers, 10 objects, so 1 to 10, starts at 1, goes to 10. So that's one way, like separating it by a colon. We can do the same exact thing. Say we'd like a sequence, please, from 1 to 10, only this time it's separated out by a comma. And if we were to run this line, it looks the exact same, right? So we get the same exact thing. So it's integers, 10 objects, 1 through 10. So if we compare these, we get the same thing. So it doesn't really matter if you separate it by a colon or if you separate start and stop by a comma, you'll get a sequence. So this is really handy when you're trying to make, a list of sequential random IDs from 1 to 4,000, because it would be really obnoxious to have to write all of those out. You can also use this same thing to skip numbers. So you can think of this as like counting by 2s or 5s or 10s. So here we have an object numbers version 2. And we're saying we would like a sequence, please. We would like you to start at 10. We would like you to end at 100. But we'd like you to please count by 10s. So that's what this by statement is. So we can run this line of code right here. And we see it here. And if we wanted to look at the list, all we have to do is call that object. So if we wanted to print the contents of the list to our console, we could just run the line of code that had the object name. And if we look down here in our console, so we see it ran it, and then it's printing out what it ran. So it contains the numbers 10, 20, 30, 40, 50, etc., because it started at 10, went to 100, and counted by tens. We can do the same thing if we wanted. We could count by 2s. So let's say we wanted odd numbers. We wanted to start at 1. We wanted to go all the way up to 197, but we only wanted the odd numbers. Not sure what you would use this for, but let's just go with it. So we're counting by twos. So we can do that. If we look over here, we see that we have 99 entries, and the first little bit that we can see that it's counting by twos. It's counting only the odd numbers. We won't read this out because we don't need to print 99 numbers to our console, but if you really wanted to, you could. You can also, with your lists, pick a specific value out of that list. So here's our 99 object list here. And let's say we wanted the 14th entry in that. So we'd use the square brackets and we'd say we would like the 14th entry, please. And so we could run this, and down here in our console, we see that, oh, okay, the 14th entry is 27. So if we started at 1 and we counted by odd, counted every other number, odd numbers, the 14th entry is going to be 27. Okay. And let's say that we wanted to save this as an object. Perhaps we were running some code where we needed to know this number and then use it later, and we didn't want to have to keep typing 27. So we could save it as an object, so val here. And if we look over here, we see that the val object is just 27. That is the number value of the object val. So then we could, in later pieces of code, we could use the object val rather than having to type in 27. And this would be useful if you were perhaps intending to change this number, then you wouldn't have to go through and change all of your code. Switching over to data sets. So we saw in the basics video that R has a number of pre-existing data sets, just that exist within it to allow you to practice some techniques. And we saw that we could print the contents of this to our console. However, what we will frequently do is assign it to an object to be able to do other things with it. So what we're doing here is we're taking the women data set, which is a pre-existing data set within R, and we're assigning it to the object df. So this is a really common abbreviation for data frame. So if we run this, now we see we have a data column or a data section. So we have this right here. We have the df data. It's a data frame. It says we have 15 observations of 2 variables. If we wanted to, we could just click on it here and we could see in a second what it looks like. We can see it's a pretty small data set. But what we can also do is, rather than having to click on it and look at it in a different window, we can examine the first couple of values or the last couple of values, the first couple of rows, last couple of rows. So if we use the function head, that's saying we'd like to look at the head of it, the top of it, and it will print out the first 6 rows. So this is like a spot check. I'm saying I just want to take a peek at what my data looks like, and if I made any changes, I'd like to make sure that my changes worked correctly. I'm just making sure that things are okay. I don't want to look at the whole entire data set. We're just looking at the first little bit. You can also look at the last 6 rows of your data set, and that uses the function tail. So you would type tail and your open parentheses. This is the name of the data set that you're trying to look at, and then close your parentheses. So if we ran this, we see the last 6 rows, so 15 through 10 here. And again, just a way of getting an idea of what your data looks like, or checking your work. With data frames, perhaps you only want one column. Maybe you want to perform a mean on only one column, or you want to perform a t-test or an ANOVA, and you want to specify the precise column that you're working with. What you'll do is you'll say, I'm working with this data frame. So I'm working with the data frame named DF, but I want the height column. And you select the height column by separating those two things with the $sign. So if we were to run this, we would see it printed out right here, because all we've said is we just want to see this right here. And so we can see the height column contains these values, and perhaps that's all we wanted to check. Perhaps we wanted to do something else with it, at which point we would wrap this in something else. We can also select by column, like by column number, column position. And so here, perhaps we don't want to call it by name, we'd rather call it by position. So here again, here's our data frame. And then with these square brackets, we're saying we want all rows, because we don't have anything before this comma here, but we only want the first column. And so if you look down here again, you can see the first column is our height column. The second column is our weight column. So here, if we're selecting the first column, it's going to call the same thing that we did by calling it by name. So if we do this, then we can see it matches up as we would suspect, because we called the same exact thing. Perhaps you have a really complicated data set or a really large data set, or you don't remember what the variable names are. If you use the function names, parentheses, and then put your data frame name within there, it will tell you these are the names in order of the variables in your data set. So it's just reminding us, hey, we have height and we have weight. Another option that we can do is print specific values, or like above, we could assign it to a variable. But we can print again. So here's our data frame. Here's our square brackets. And this time, notice that we have both a row designation and a column designation. So this is telling R to, in this data set, in the DF data frame, please go to the fourth row, the first column, and give me that number. So that is 61. So that is, the cell that is in the fourth row, first column, value of that is 61. Other things that we might want to do is maybe we want to rename our columns to better suit our analysis, better suit our understanding, just to remind us so we don't have to constantly remember, what some random value is. It might make sense to us more. And so here, this is that same names function that we saw up here to get the variable names. Here's our output again as a reminder. Oops, down here. And so what we're saying is for this, for the first entry, so this one right here, instead of it saying height, we want it to now be height in inches. So we just want to remind ourselves that it's height in inches, or maybe we're sending this off to somebody else and that would make more sense. That's what we want this column name to be. So if we were to run this, we don't really see anything, right? It says, okay, cool, we did this thing. But we can use this head function again to check our work. I think I renamed this column, but did I actually rename this column? So if we run this, we see that now it says height in inches and weight. So we have successfully renamed our column. Another way that we can do this is, again, rather than referring to it by position, we can say, okay, names again, but then this time, if the name is exactly equal to, oh no, don't move, exactly equal to, that's what the double equal sign is, height in inches, we now want that to just say height. So we're changing it back. We can do that, and it says, okay, done. And we can check our work, and we see that it is back to saying height and weight. So just two different ways of changing column names. Both of them end up in the same outcome. Perhaps you'd rather refer to it as position. Perhaps you'd rather than figure out where it is, just say, this is my column name. This is the old column name. This is what I want it changed to. We can use the table function to get a count for each value. We can go table, and here we're saying we just want the height column. So this is our data. This is saying column, and this is the column, that we want. So we did that. This one, not terribly useful because it's only one entry for every single value. But if you had multiple entries per value, then this would be, a different way of looking at your data. So what we can also do, there's another data set, just as another example of kind of what's going on. And that data set is called MT cars. And so we can say, we would like to assign that to the cars object, please, and run that. We see it's up here in our data. We can see, well, what's the variable names? This time we've got a lot more variables, right? Miles per gallon, cylinders, I don't know what that one is, horsepower, weight, gearing, etc. And so we can see that cylinder is one of the variables. So to get something that is a little bit more interesting than this, we can say we'd like a table, please, of our cars data set this time, the cylinder column, please. So if we were to run this, okay, we see that the options were 4, 6, or 8 cylinders. We see that 11 of the cars in this data set had 4 cylinders, 7 of them had 6 cylinders, and 14 of them had 8 cylinders. So if you had something that was, fewer, or you wanted just kind of a count of how many was in each one, the table function is a really nice option for that.